Hey everybody, today we're going to talk about dissociation of acids and bases and neutralization reactions. If you're in my class, we'll be looking at the note pages that say those for this unit. So far we've talked about acids and bases and how they dissociate or separate when you put them into water. Like for instance, hydrochloric acid, which is one of the stronger acids, it will dissociate into both hydrogen ions and chloride ions. Alright? Those hydrogen ions, as we can see in the picture right here, will attach to a water and make hydronium, H3O+. And then the chloride ions, Cl-, will float around in the liquid. Hydrochloric acid is what we call a strong acid because all of it will dissociate in the liquid, or mostly all of it. And so it's going to donate many H+ ions to water, as it says right there. Strong acids have weaker bond strength, and so they more easily separate from one when they get put into a liquid. Weak acids, on the other hand, dissociate or ionize incompletely in water. Something like hydrofluoric acid, they have fewer H+ ions added to water because they have a higher bond strength, like fluorine and hydrogen have much higher bond strength because of fluorine's electronegativity, so it will not separate as easily in the water. So some of it will stay together, some of it will still donate and have ions. Okay, so strong acids donate completely, they ionize almost completely and donate lots of hydrogen, whereas weak acids do not. Strong bases are pretty similar, except of course they're going to be ionizing completely and donating a lot of OH-. Like sodium hydroxide, NaOH, is one of the strongest bases. When it separates in water, it's going to donate a lot of hydroxide ions into the water. Weak bases, just like weak acids, ionize incompletely in the water, so they're not going to donate as many as the strong bases would. Alright, like NH3 ammonia is a weaker base. It's still going to take some hydrogen from the water and create OH-, but it's not going to donate and separate as strongly as like sodium hydroxide does. It says in your notes here the strong acids and bases, and I'm also written it over here for you. So your strong acids are these 6 are your major strong acids: hydrochloric, hydrobromic, hydroiodic, and then nitric, sulfuric, and perchloric. These 3 are pretty easy to remember because they're all halogens. They're all chlorine, bromine, and iodine are all in group 17 on the periodic table. Nitric and sulfuric and perchloric are all made from polyatomic ions. You'll have to remember those. Strong bases is anything from group 1 or group 2 with hydroxide. So NaOH, KOH, MgOH2, BaOH2 are examples. Barium hydroxide, magnesium hydroxide, potassium hydroxide, sodium hydroxide. So anything with a group 1 or 2 metal with hydroxide is going to be considered a really strong base. Alright? So recap. Strong ionizes completely. Lots of ions in the water. Weak ionizes incompletely. Not as many ions in the water. Okay? So one of the reasons we need to know strong and weak acids and bases is because of neutralization reactions. When acids and bases get mixed together, they're going to neutralize each other. And this makes sense because if we look at what an acid and a base does, they're geared to neutralize each other. Remember, acids, they always like to donate NH+. Bases either donate or help form OH-. Well, if you put H+ and OH- together, you get H2O, which is water. So an acid and a base ions together make neutral, water. So acids and bases, when you mix them together, are going to usually form ionic salts in water. Okay? Strong bases will neutralize strong acids, and weak bases will neutralize weak acids. Okay? It says here in the notes, could you neutralize a weak base with a strong acid? Yes, you could, but you would need a lot of the weak base in order to neutralize the strong acid. Okay? Or you would need a very small amount of the strong acid to neutralize that weak base, because it's their relative strength that has to do with how much molarity is going to get put in, what concentration. We can do something called a titration in order to determine the exact point at which an acid or base is neutralized. So this guy here is performing a titration. He's slowly adding a weaker acid to the water, or to the base, and then at the point where they become neutral, that's called the end point, or the neutralization point rather, and that is when the H3O+ concentration will equal the OH- concentration. Okay? If you have to neutralize an acid and a base, then it's going to be the molarity times the volume of the acid equals the molarity times the volume of the base, because that means the moles of acid and base are equal, and if you have exactly equal amounts of acid and base, of moles of acid and base, the H+ and the OH- will cancel out to form water. Okay? So here's some examples of neutralization reactions right here. So good thing with neutralization reactions is you can pretty much always know what one of the products is going to be. The H and the OH from the acid and the base are always going to come together and form water. So I know all three of these are going to form water as one of their products. It's the other product that we're concerned about. So this other product is an ionic salt, and by salt I don't mean necessarily table salt. An ionic salt can be any ionic compound with a metal and a non-metal from two ions. So to figure out what your ionic salt is going to be, realize that you're getting the cation from the base and the anion from the acid. Okay, the OH and the H were used to make the water. So whatever's left, that's what's going to be used to make our ionic salt. The only thing you have to make sure is that the ions balance. Like Na is a positive 1 from group 1. Chlorine makes a negative 1 from group 17. So those will balance each other out. So the ionic salt made in this reaction is NaCl. Okay? Take a look at the next one. H2SO4, NaOH. I know the H's and the OH's are combining to form water. So the Na and the SO4 are going to combine together. So NaSO4. Okay? But be careful because, like I said, you need to check out the charges to see how they're balanced. This is incorrect because the charges aren't balanced. Sodium likes to form positive 1. SO4 is sulfate and it forms a negative 2 charge. Okay? So when those guys combine, it's going to be 2 sodium, so it's Na2SO4. So on this last one, we've got hydrochloric acid and calcium hydroxide. The OH's and the H will make the water, so it's going to be calcium and chlorine, and I can see that this calcium is a positive 2 because it took 2 hydroxides who have a negative 1 to balance out, and so since chlorine is also a negative 1, it's going to take 2 chlorines to balance out that calcium. So CaCl2 is the ionic salt for that guy. Okay, so this is how neutralization reactions work. So, if you're in my class, you have an assignment on this. If you're not in my class, you already got the information you need, but you can keep looking. So, neutralization reactions, this is your neutralization assignment. Neutralization reactions occur when an acid is added to a base. The products are, it says a slat, that is not correct. The products are a salt, not a slat, and H2O. A salt is any compound formed by a negative anion coming from an acid and a positive cation coming from the base. The neutralization reaction can be identified by the acid and base on the reactant side of the equation and salt and water on the product side. So on these, you're just telling me, is it a neutralization reaction? So you want to look and see if it's got water. If it's got water and it had an acid and a base on that side, and the acid cation, the acid anion and the base cation form the salt, then that's going to be a neutralization reaction. So that one is one. Okay. On these pages, you're going to see a table. And in the table it says parent acid, parent base, and it's going to want the salt form, or it's missing one of the other two. Okay, so to figure those out, all you got to do is write them down and figure out what you're missing. So parent acid, parent base, for example, HCl, NaOH. If that's the acid and that's the base, the H and the OH make the water, so my salt is going to be NaCl. Na from the base, Cl from the acid. You got to check the charges to make sure they balance. In this case, they do. So that would be NaCl in that blank right there. On these other pages, you're going to have the acid and the base, and it wants to know what salt are they going to form in a neutralization reaction. So like that top one is H2CO3 and NH4 ammonium hydroxide. So like I said a couple times, the hydroxide and the hydrogens are being used to make the water. So this positive ion and this negative ion are going to be used to form the salts. So NH4CO3, I got to check the charges. Ammonium forms a positive 1 ion. Carbonate forms a negative 2, as we can see from the 2 hydrogens. So it's going to take 2 of those ammoniums in order to balance out that carbonate. So it's NH42CO3. So you just go up here and you get the drop down menu NH42CO3. Okay? Hope this helped you guys understand neutralization reactions. If you need some more help, ask me in class tomorrow. Have a good night.